I'm gonna hit share screen here. We're gonna go here, and then I'm also gonna hit, see if it lets me record all the things. Okay, so I think we are recording on 2 different systems right now, so if this doesn't record, I'll be very sad. But we are back in the Ms.Hsummersessions notebook that you have access to both the science and the math section. You'll notice in science we have the intro to chemistry that we did last Thursday, as well as the beginning of the conservation of matter. Today we will be discussing chemical and physical changes. And I was super excited to come home to do this because we have plenty of supplies and experiments to do that I hope you will recreate at home. Some fun summer learning, but also maybe you'll get ice cream out of it. You'll notice here we also have our math section. I am going to continue to diligently try to find the video that we made on Monday of all of this content, but you'll notice here we have some definitions, some practice questions, some examples, some workout, and then up here in the corner we have a equations on both sides practice sheet with the answer key and how it was worked out if you need help with that. So we are going to go back to science because it's Thursday, chemical and physical changes. So anytime something happens to something in the world, it's classified as either chemical or physical. When you bake a cake, when you drink a beverage, when you turn your car on, everything that happens in the world is either chemical or physical. Or chemical indicates that a permanent change has been made. And I can spell permanent. A permanent change. There we go. I knew I didn't spell permanent right. A permanent change has occurred, meaning chemicals have reacted with one another. Physical means that a physical means has happened. Something that can physically be undone is possible. If I saw the top of a fence off, I can glue it back on. If I paint a fence, I can strip the paint right back off. So physical is something that can be undone. Now, I told you we're basing this off of the standards that you are going to have to know in 8th grade, so let me show you what those look like real quick. What we're talking about here is constructing an argument based on observational evidence. Blech. All of that means is what you're going to do is observe some experiments today, and because of what you see, you're going to be able to argue that this is a fact. That's supporting the claim that when a change in a substance occurs, it's either chemical or physical. So what you're going to do is you're going to observe a change, and then you're going to argue whether it's chemical or physical. And you're going to do that based off different examples you're going to see. The evidence that we're talking about is separating a mixture. You're going to see today when I separate salt and water. The development of a gas that you're going to see today when we mix baking soda and vinegar. The formation of precipitation, which we can do by boiling water. Changes in energy, color, or form. You're going to see a change in form today at the right at the beginning here. We're about to make ice cream. We are going to change something from a liquid to a solid. So we're going to do a few examples, and I'm going to explain to you why they are physical, why they are chemical, and then I'm going to leave you with some questions for you to answer and tell me if you think it's physical or chemical. So today is mostly experiments. So remember I have this recorded in so many places, it will go on YouTube so that you can do them at home later or whenever you want. So the very first thing we're going to talk about is a physical change. Physical change. This is something that can change back. So the example we're going to show you is a liquid to a solid. This is going to be done by making our own ice cream. So we have some supplies here already made. Things that you're going to need are a smaller sandwich Ziploc bag, a gallon size Ziploc bag, and make sure to, if you do have the nice like hefty real Ziploc, try those, the dollar store ones. No shame to the dollar store, it's my life. They do tend to break, and then you get salty ice cream. It's not cute. So in the smaller bag, what we're going to do is add, pardon me, one cup of milk, and I'm going to do this over the sink because I have learned in my life that I am not very skilled. We are going to add 1 tablespoon, your thing should say capital TBS, 1 tablespoon of sugar into our bag. We are going to make sure that our bag is upright. Do not let that spill over all over your family's counter. Then we're going to do 1 teaspoon, 1 TSP, small teaspoon of vanilla extract. I feel like a YouTuber. Vanilla extract. And make sure, again, not to spill. And we are going to put that into the smaller bag. So what you have are your contents of your ice cream, your delicious vanilla sugary ice cream. And we are going to remove all the air from the bag, gently pressing it. Don't like squish, okay? Gently pressing it. Make sure that Ziploc is so nice and tight. Don't want any holes. I recommend you do this over the sink, but dump it over. Make sure that none of your content falls out. Make sure it's all nice and mixed up. That is bag 1. In bag 2, because Ms. Humphreys is a science teacher and she's ridiculous, she has something called ice cream salt. Rock salt. It's more commonly known as rock salt. If you want to get this, to do this with some family and friends at home, you absolutely can. However, natural salt works just as well. I am going to use the rock salt just for the best effect. So I am opening my rock salt, and I'm going to put, how much in this large bag, Mom?
Tablespoons.
A couple tablespoons.
You can just shake it.
You can just shake it in. It's a very exact procedure at this point. Is that about a couple tablespoons?
More.
More, okay. This is where we get exact. How about that?
We'll probably put some more in after we put those.
Okay. All right. So we have, for a more scientific reference, we have about the bottom of the bag covered. So we put put rock salt in here. Okay. We now have about up to the middle of the bag where it says hefty. We're going to add a little bit more salt on top. Make sure your ice is nice and coated in salt. Ta-da. Then place your liquid mixture bag into the ice solution, making sure it's covered. This is why it's super important to make sure your bag is sealed, because if you don't have this sealed, you're going to end up with just a bag of icy, salty milk. Okay. Get it buried down deep in there so that it's completely submerged in the ice. Ziploc this closed and pass it off to your handy dandy assistant.
When they do it, they're going to need to use like
Yes.
towels or something because it gets really cold.
Okay. your handy dandy assistant and or you, because you're at home, are going to need to protect your hands. Hold on, I can't hear me. Protect your hands because we know that ice is frozen. So at minimum, it is 32 degrees. Your hands are going to get very cold shaking 32-degree ice. However, you're not holding just ice. You're holding rock salt ice. And come back next week when we talk about the properties of matter to understand why we can change freezing points and boiling points of substances using other substances. So come back next week to learn why we put salt on frozen streets and why it's going to help us make this ice cream. But what's happening right now is that milk is going through a physical change because it's changing its state. Let's look at a chemical change where we can't make that go back. If you leave ice cream out of the freezer, it's going to melt. It's going to become a liquid again, okay? So let's look at some substances we can't change back. One of our favorites, baking soda and vinegar, of course. So if we take one chemical, just baking soda, that has its own properties that release gas, cause substances like carbs and cakes and breads to rise, its natural reaction is to release a gas. If we add distilled vinegar to that, whose natural reaction is to release a gas, those two gases are going to come together to create a chemical reaction. So I'm going to actually get rid of some baking soda because I have a bit too much. And I don't actually want to trash my whole mom's kitchen because then I'll have to clean it up. This is leftover baking soda. All I have in here, this is leftover vinegar. All I have in here is baking soda. And I am simply going to create a chemical reaction. Now, we saw the air bubbles come up. We saw the oxygen get released. We saw the gases separate. Now, the problem is that no matter how hard I try, no matter how long I leave this out in the sun, we are no longer going to get ever just baking soda, and vinegar will evaporate. These two chemicals have now combined to release another chemical, and there has been a chemical reaction. We have baking soda and we have vinegar. Now, let's look at the opposite of that, which is salt and water. Water and salt is actually a physical reaction because you can separate those back out. It tastes like salt water. Those two aren't creating a new chemical. So what I'm actually going to do here is I'm going to take some plain table salt, and I again encourage you to do this at home. Take some plain table salt. I'm going to put it in this empty cup. I feel like a magician. I'm going to put it in this empty cup. It'll shake out. And I have a cup of water. Now, to prove to you that these are the only things I'm adding in here, I also have an empty pan. I am actually going to pour this salt over the pan. Pour the salt over the pan. That's all that's on it. And I am now going to fill this pan with water. Get some more water. Okay, now we can argue, but Ms. Humphreys, they mixed. It looks exactly like this. It's a substance. It looks exactly like this. These two substances have mixed. Why are you telling me this is different? Because I am going to leave these two things out. I'm going to leave this out in the sun, and I'm going to leave this out in the sun. Tomorrow, this will just be a dried clump of vinegar and baking soda. This will be only salt left, okay? A chemical change cannot be chemically undone. A physical change can. It physically is altered. So if I am going to take a fence, if I paint the fence, is it physical or chemical? Physical, because I can unpaint, because I can take that back off. Stretching a rubber band. If I stretch this rubber band all the way out, what's going to happen? It's going to stretch back. Even if I break it, there's still the same amount of stretch in this. There's elasticity. The chemical bonds are not changing. We're dissolving water. Cutting your hair. Hopefully when you cut your hair, there is not a chemical change happening. You're simply physically changing what we're doing. Hopefully that gives you a better idea of the differences in physical and chemical changes. Excuse me, sorry. So when we're going back to that fence, so things that we're talking about with that fence are sorry, hold on. Sorry, anything's going on. Sorry, hold on, guys. Okay, so when we approach that fence as our physical or chemical, a fence is a great example. If we paint the fence, if we cut the fence in half, those are physical changes that we can move, that we can do something with. A chemical change would be an example of burning the fence. Those oxygen particles are being released into the air, the carbon is being released, we can't unburn a fence, okay?
Ms. Humphreys?
Yes.
Hey, sorry I'm late. I just got back from a walk and I was thinking, I didn't read the text all the way. I was thinking it was on Teams, so I kept refreshing the computer.
Okay, hey, we're recording that's gonna go out on YouTube, so you can't talk, okay, because it's illegal.
Oh.
You're a minor, all right? Message me on the thing, okay? Okay, so again, this is gonna go on YouTube right after it's posted, so don't worry if you guys missed anything, if you stepped away, if you just showed up, it's totally okay. The whole thing will be on YouTube. So baking a cake is the most common example that teachers give you. When you bake a cake, you put flour, you put baking soda, use that box mix that you get. It has flour, sugar, baking soda, all of these things. You add the eggs, you add the milk, you create a mixture, and we'll do elements, compounds, and mixtures soon as well. But you create a mixture. As soon as you put that mixture into the oven, that baking soda, baking soda that we just talked about, releases its oxygen, it creates a gas. That gas is released, that you see those nice little holes in your cake where it's all nice and light and fluffy. That chemical has been released. A change in chemicals has happened. So that is the best way to explain chemical and physical changes. I hope I didn't talk too fast. I know I do that all the time. We've done some great examples. I will post pictures on the blog tomorrow of what our cornstarch, or excuse me, baking soda and vinegar look like, as well as what our pan of water looks like. And I want to take a second to check in on our ice cream that we started at the beginning. Remember, this has been shaken the entire 17 minutes we've been on here. So, look, this is no longer liquid. This is a solid, and I bet it's solidly delicious. And I'm going to take a bite. Just like that, homemade ice cream. That's banging, I'm not gonna lie, y'all. Science, make your own ice cream. And as a teaser,
-15. So 0.
As a teaser for next week's Properties of Change video, the ice that bag is frozen in is now -15 degrees Celsius rather than the freezing point 0. So how is it possible that salt can make something so much colder? Check back. I will see you on Monday when we discuss whatever Ms. Humphreys figures out to discuss in math. And yeah, see you on YouTube. All right, stop recording.